Good morning, listeners, and welcome to my CHEM1090 vlog assignment all about silicon dioxide. In this vlog, I will be talking about why silicon dioxide is so important, as well as why it's personally important to me. Silicon dioxide, or silica, as it's commonly referred to as, is important to me because it is the discovery of this molecule in its crystalline form that led me on my path to wanting to be a geoscientist. When I was young, I remember wandering the schoolyard and finding a large clump of quartz that I admired. Since then, I have always wanted to be a geoscientist. Not only is it an extremely abundant mineral in Earth, it also plays a large role in the building industry, so without it, I wouldn't be studying what I am now. Silicon has an electronegativity of 1.9, whilst oxygen has an electronegativity of 3.44. From this, we can see that they have a difference in electronegativity of 1.54, showing that this molecule is formed of covalent bonds. In the periodic table, silicon is number 14, meaning it has 14 protons and electrons. In silicon's first energy level, there is 2 electrons. In the second energy level, there is 8 electrons, all of which are stable. In its third energy level, however, there are 4 valence electrons. Oxygen's first energy level is also full, but due to it having 8 electrons, it has 6 valence electrons in the second energy level. Seen from this, it would look like the silicon atom would have 2 double bonds with the oxygen atoms. But this is not correct, unlike carbon dioxide, which does. Silicon dioxide naturally appears as a tetrahedral structure where the silicon atom is bonded to 4 oxygen atoms. The bonds between the silicon and oxygen atoms in this tetrahedral structure have a bond angle of approximately 110 degrees. This tetrahedral structure in silicon dioxide is what gives it its strength and stability. This is demonstrated by its high boiling point of 2230 degrees Celsius and high melting point of 1610 degrees Celsius. It is further demonstrated by silica's hardness on Mohs hardness scale. Now it's at this point that you might be thinking, but wait, if carbon dioxide and silicon dioxide are so similar, why does silicon dioxide favor this tetrahedral structure? This happens because of the size of the silicon atoms. The length of the silicon to silicon bonds is very large in comparison with the carbon to carbon bonds, and due to the bond lengths, a double bond just wouldn't be stable, so silicon dioxide favors a stable arrangement, and this is a tetrahedron. For these reasons, silicon dioxide has many practical uses in the building industry as a main component in concrete and building foundations. Also, because of its high melting point and stability, it is used across the world as an ingredient in insulating wires and is also used in watches, windows, metal alloys, and many other objects across the globe. Without silicon dioxide, the world, and me personally, would be very different to what we are now. Thank you.